Welcome to Math 8, Unit 4, Lesson 11. This is your homework help. First thing, Diego has $11 and begins saving $5 each week towards buying a new phone. At the same time that Diego is beginning to save, Lynn has $60, but she's spending $2 every single week on supplies for her art class. We have the question here. It says, is there a week when they have the same amount of money? So that's going to be our variable. We're going to say let X be number of weeks. Whoa, sorry, I don't know what I did there. Using a new subscription tool. So let X be the number of weeks. When we talked about this, we have Diego. He starts out with $11 and he's saving $5 every week. And then we have Lynn, who has $60, but she's spending $2 per week. And so what we want to do is find out this piece that says at what point would the X be equal to each other? What point would Diego have the exact same amount of money as Lynn? And so how many weeks would that be? So we just set these up to find out what is the value of X. Add the 2X to both sides. I'm just going to go really quick through this. Hopefully we're doing these using the property of equality to be able to find out that after division property, X is equal to 7. So we know after 7 weeks, they have the same amount of money. But then how much money is that actually going to be? When we look at that amount of money, what we need to recognize with that is when we talk about Diego and we're talking about Lynn, we're talking about, I'm substituting that 7 back in. So we're saying that $11 a week plus $5 every week for 7 weeks, we have 11 and 35, which is going to be equal to $46. But we can't just stop there. We have to talk about Lynn. We have to talk about the fact that she's got $60 a week and she's spending $2 a week for 7 weeks. So that's subtracting $14. And so 60 minus 14 is also $46. So I know that we have $46 to work with at that time. All right. Next question. We're talking about using a graph to find the X and Y values that make both the equations true. So we're looking at these two values and saying, when does this equation intersect with this equation? So what I'm going to do is I'm going to start with the blue pen and go ahead and just start graphing these two equations. We'll do this one in blue and then the other one in a different color. So we start with the y-intercept of positive 3. And we're going to go ahead and follow that slope by rising negative 2, running positive 3. And I want to do that all the way across the plane to make sure that I'm looking at all of the possible points. Looks like I got a little schmutz there. We'll take that off of there. And now we want to do the other one, starting at negative 5. And rising 2, running 1 until the lines intersect. And it looks like we're going to get lucky because right here, what just happened is these 2 points, we have a blue point and a red point right there that intersected. So what we know is that these 2 lines intersect at that one single point. If I was to draw that on there, I don't know if I can get a very straight line. I haven't found that tool here yet. But if I get that line there, and this line here, we would see that intersection at 3, 1. So plug it in one number per box. Question 3 talks about 2 equations where they have a common intersection where it's talking about through a point where we have the y-coordinate is 2, so we have something and 2. One equation is y equals negative 3 times x plus 5. The other equation, we really don't know what it is other than the slope is 1. What we do know is that if they intersect at this point, this is a big piece of information for us. If they intersect at this point, then we should be able to use just that y-coordinate given this equation to find the x-coordinate, and then we can use that to find the y-intercept of the other equation. So when we check this out, if we know what y is, we can substitute and say 2 is equal to negative 3 times x plus 5. And then we go ahead and just use our properties of equality. figure that out a little bit later. Properties of equality to solve for x, and we find out that x is equal to 1. So this is the intersection. Now that doesn't tell us what the equation is, but with that intersection, what we can do now is we can use that ordered pair to figure out the other equation. Right now, what we know about the other equation is just that y is equal to 1 times x. Plus, I don't know the y-intercept. I know that the slope is 1. That's how I can put that in there. But now knowing what x and y is supposed to be, I can now substitute 2 for y, and I can substitute 1 for x, and then I can solve for the y-intercept and get the very last piece. So right now I know this is y. What I can do over here now is 2 is equal to 1 plus b. I can subtract 1, and I find out that b is equal to 1, and I can finish my equation to know that my equation here is y is equal to 1 times x, or just x plus 1. Last question. 2 parts. You've got this one. I love these farm questions. A farm has chickens and cows. The cows have 4 legs, and all the chickens have 2 legs. Altogether, there's 82 cow and chicken legs on the farm. Complete the table to show some possible combinations of chicken legs and cow legs to get 82 legs. And honestly, what I really like about this one, or what I like to do with these ones first, is I really, really like to have an equation, because that equation simplifies the whole thing for me. We know the number of chickens is x. We know the number of cows is y. We know every chicken has 2 legs, hopefully, and every cow has 4 legs, and altogether they've got a total of 82 legs. And the reason I like to use this is because with these other values, when they're given in here, 35 chicken legs, how many cows are left? Well, I can go ahead and use this to help me out and figure out this number times 2 plus this number times 4 is equal to 82. And I have that blank space to figure that out. So the first thing I want to do is 82 minus 70. We'll go ahead and use our calculator here. Actually, see if I can use this one on here. And here we go. 82. Well, I don't know how to use that calculator. Let's see if I can get this. Sorry, I'm just trying to understand how to do this one better. We'll go right here. Maybe not. All right, since that's not really working for me, I'm going to switch back to this one. What I want to look at here was, like what I said, 2 times x plus 4 times y is equal to 82. And I want to just use that as I'm working through. So when I go to my calculator, what I want to take with that is just work backwards. I know that 2 times 35 gives me 70 legs. 70 legs, what's left? 82 minus 70 tells me that I have, 82 minus 70 tells me that I have 12 legs left. So in those 12 legs, 12 divided by 4 is going to be 3. All right. And then with our next one, what we're going to work with is 7 chicken legs. That tells me that there's a total of 14 legs there. And then how many cow legs are left? Well, we're going to take our 82 and we're going to have to subtract 82 legs minus the 14 legs that are given, which is 68. Divide that by 4, and that tells me that I have 17 cows when there's 7 chickens. Hopefully what we can get to at this point is there might be some kind of a constant or pattern, but I don't see any pattern that's here. So what we're going to do is just continue like what we're doing. 40 cows, that's going to be our 10 cows, that's 40 legs. 82 minus 40. But this time, what we're going to do is we're going to divide that by 2 because that's the number of chickens. So we have 21 chickens in there. So continue that out and you can get that one finished up. What we're after that is we need to go ahead and look at the graph. Here's the graph that shows the possible combinations of chickens and cows that add up to 30. So if you were hoping to use this graph to help you with the other one, it may or may not work for you, but it might help somewhere in there. When we're looking at them, we want to ask these questions. How many chickens and how many cows are on the farm? So here's a graph that shows the possible combinations of chickens and cows that add up to 30 animals. If the farm has 30 chickens and cows, and there are 82 chickens and cow legs all together, so 30 animals with a total of 82 legs, then how many chickens and how many cows could the farm have? We want to be able to figure out on this graph where we would find X and Y having a sum of 82, or excuse me, a sum of 30, and then having the number of cows or legs and all that adding up to 82. What we really want to get from this is we now have two equations. We have the equation, when we really think about it, 2 legs per chicken, 4 legs per cow for a total of 82 legs. But then we also introduced this other equation that any number of chickens plus any number of cows can only be equal to 30. So there's our maximums. We have to figure out what value for X and Y adds up to 30, but it's also a value that is for X and Y that adds up to 82. That's kind of a tough one in here. So I'm going to tell you to go ahead and play through it just a little bit, see what you can come up with. We will find out strategies for how to solve equations like this. But for right now, I want you to figure out how many chickens and cows. I'm going to leave that one to you. Good luck to you on that one. Thanks for doing your homework. Let me know how I can help. Have yourself a great day.